Hey everyone. So in the last video we started with the interpretation of a basic OLS regression with continuous dependent variable and two independent variables. One that was also continuous and one that was dichotomous, so 0 or 1. And now we kind of look at a slightly more complicated case where we include an interaction between the dichotomous independent variable and the continuous independent variable, right? And so in this case, we have an additional parameter that we're estimating. And this additional parameter, beta 3, is the parameter for the interaction. So the product between x1 and x2. Okay. As soon as we have this interaction coefficient and this interaction included in our model, our interpretation of the two previous coefficients also changes slightly. And one has to be careful to kind of take into account this interaction term when interpreting the remaining coefficients as well, right? Again, I have some simulated data with the regression output presented here, as well as presented graphically in a scatter plot. We have our coefficient for x1, which is 0.85. We have our coefficient for x2, which is 1.5 approximately, and our interaction effect, which is around 0.56. Okay, so how can we interpret these coefficients? What do they ultimately mean? Let's start with well, the first thing that I didn't include here is, of course, the intercept. The interpretation of the intercept is kind of the same as before. We talked about this. Holding all independent variables at 0, the expected value of y is alpha. And that, of course, still holds. Holding x1 and x2 equal to 0, the expected value of y is equal to alpha. So that's basically what we see right here. Okay. Now let's move to the interpretation of the slope coefficient, the continuous independent variable, so the coefficient beta 1 for x1. Okay. The interpretations change slightly because now the slope, as we said before, as I emphasized in the previous video, when we had just the continuous y and just the parameter for x1 and a parameter for x2, we said that the slope beta 1, the effect of a 1 unit increase, or the expected change of a 1 unit increase in x1 that is associated with increase in y, is constant across groups that are identified by the dichotomous indicator, right? And so now, as soon as we include this interaction, this is not the case anymore. Now the slopes differ between those two groups, okay? And so now the effect, the coefficient beta 1 that we see, we have to interpret it as not only holding everything else constant, but also holding x2 as equal to 0. Okay, so holding everything else constant and x2 equal to 0, that's the dichotomous indicator. A 1 unit increase in x1 is associated with a beta 1 increase, decrease in the expected value of y. Again, whether it's an increase or decrease depends on the sign of beta 1. If it's positive, it's an increase. If it's negative, it's a decrease. The important point here is that this beta 1 parameter basically describes the slope for this reference category where x2 is equal to 0. So those are all the red dots in our figure, and the beta 1 coefficient is basically the slope coefficient for that red line. Okay, and that, of course, is only for those observations for which x2 is equal to 0. Okay, and then we have our coefficient for the dichotomous independent variable x2, and that again changes slightly in the sense that now we have this intercept shift again, but this intercept shift at a specific position on the range of x1 values. Okay, so we interpret the coefficient for the dichotomous independent variable as holding everything else constant and x1 equal to 0. So again, we hold the other variable that is part of the interaction equal to 0. The expected value of y is increased or decreased by beta 2 when x2 is equal to 1 instead of 0. right? So that's quite similar to the previous interpretation of the intercept shift that we talked about in case 1. The only difference is that the size of this intercept shift is now the size of the shift where x1 is equal to 0, right? So we're shifting the line by beta 2, but only at this point. And as you can see, of course, the slope of the blue line is different from the slope of the red line, which implies that this intercept shift is not constant, right? It's not constant across ranges of x, right? So beta 2, the coefficient, gives you information about the shift of the intercept at x1 being equal to 0. So that's this shift right here, okay? Now, as I mentioned, the interaction allows us to model or take into account the possibility that between the two groups, x2 equal 1 and x2 equal 0, not only that the intercept shifts, but also that the slope of the slope coefficient, or the slope is different. So the relationship between x1 and y differs between those two groups, right? And so the way this slope changes depends on the interaction term and is crucial to how we interpret the interaction term, right? So the interaction term beta 3, which is the coefficient that is basically associated with the product of x1 and x2, can be interpreted as follows. Holding everything else constant and x2 equal to 1, a 1 unit increase in x1 is associated with a beta 1 plus beta 3 increase or decrease in the expected value of y, okay? So now we said before that beta 1 describes the change in y that is associated with a 1 unit increase in x1, right? Now if we want to examine how what change in y we expect for 1 unit increase in x1 when x2 is equal to 1, basically what we have to do is we have to add beta 1 and the interaction term beta 3, because as soon you can kind of, if you look at the original model specification, if x2 is equal to 1, this term cancels out. And if we want to examine how this function changes, or how this equation changes as a function of x1, we can take the first derivative with respect to x1 for the case where x2 is equal to 0. So this cancels out and this cancels out. So we are left only with beta 1 as the slope coefficient, right? As soon as we have x2 being equal to 1, we have a case where this part doesn't drop out. So with every 1 unit increase in x1, it's not only a beta 1 increase, but it's beta 1 that increases, or it's not only a beta 1 increase, but it's beta 1 plus beta 3, because x1 here is increasing by 1 unit and x2 is equal to 1. So that together means that the slope of the blue line, which is the change in y associated with a 1 unit increase in x1 for x2 being equal to 1, is beta 1 plus beta 3, right? So in other words, if we just focus on beta 3 itself, it tells us how much the slope changes between the reference category, right, where x2 is equal to 0, and the other category where x2 is equal to 1. So beta 3 is what we add to that slope coefficient in the reference category, right? And so of course, if beta 3 is negative, that means the slope is slightly lower, or could even change signs essentially, okay? But the key part, of course, is to recognize, to kind of compare these two cases. One, the continuous y, where we just have two separate independent variables, one continuous and one dichotomous, where the slope is constant across both groups. And then to see, as soon as we include this interaction term, then the slope can differ between those two groups. The blue line and the red line can have a different slope, okay? And the interaction term is what kind of tells us how the slope differs, right? How the slope between the reference category and the category where x2 is equal to 1 changes, okay? And so that's what we see in the interaction term, okay? One quick note is to keep in mind that when we have an interaction between a continuous independent variable and a dichotomous independent variable, in most cases we want to kind of look at this from the perspective of how does the slope change when x2 is equal to 0 versus x2 being equal to 1. In theory, you can also kind of flip around this interpretation, right? You could also think about not, and I kind of hinted at that earlier on, you can also think about this not in terms of how does the slope change between those two groups, x2 equals 0 and x2 equal 1. You could also interpret it in terms of across ranges of x1, how does this intercept shift between x2 equals 0 and x2 equal 1 change, right? And so this is what we mean, this is kind of describing how this beta 2, this intercept shift, I mentioned that the beta 2 interpretation is only interpreted as the intercept shift where x1 is equal to 0, and so that's that shift here. And you could kind of think about how as we increase x1, this intercept shift becomes larger. As we decrease x1, go further down here, this intercept shift becomes smaller, right? So both things are essentially equivalent. This interaction term tells us essentially both. On the one hand, it tells us how the slope changes between x2 equals 0 and x2 equal 1. But at the same time, both are mathematically equivalent. It tells us how this shift between x2 equals 0 and x2 equal 1 between those two lines changes and becomes larger or smaller for smaller values of x1 or larger values of x1, right? So depending on what parameter you're ultimately interested in, you might be interested in interpreting the interaction term in one way or the other. It depends a little bit on what your substantive research interest could be. So for example, if you have an experiment with a treatment indicator that is 0 or 1, and your continuous variable is something like education that is a moderator, you might be interested in how the treatment effect changes for different values of education. And then you would use and think about this interaction term in terms of this second interpretation. In other cases, for example, when the dichotomous indicator is the moderator, so for example, suppose it would be gender, and you're interested in whether the effect of, I don't know, education on turnout differs by gender, then it would be this first interpretation that I talked about, where we talk about how the slope changes between those two groups. But the key thing is that you can always interpret it, depending on your substantive interest, you can interpret the interaction coefficient in either way depending on your substantive interest, because ultimately whether you think about this as the shifting change between the shifting change between the red line or the blue line, or the change in the slope between the red line or the blue line, both are mathematically equivalent. But it helps to think about how both of those are related, and then make sure to choose the right interpretation for your substantive question that you're interested in.